All right, let's break down a huge programming concept using something you do almost every day. We're going to connect writing really good code with, believe it or not, driving a car. And by the end of this, you'll get one of the most important ideas in Java, abstraction, just by thinking about getting behind the wheel.
So, let's just kick things off with a question. What on earth could driving a car possibly have in common with writing clean, efficient code? I know, it sounds kind of weird, but the answer really gets to the heart of what makes for smart, solid software design.
So to figure that out, let's start somewhere really familiar for all of us. Just sitting in the driver's seat of a car.
Think about it. When you hop in a car, you only have to deal with a few specific things, right? You've got the steering wheel, a couple of pedals, and the gear shifter. That's it. It's this simple standard set of controls.
And it's all about cause and effect. It's super predictable. You press the gas, the car goes faster. You turn the wheel, the car turns. And the beauty of this is that you get to focus on the important stuff, the road, not the machine itself. And here is the absolute key to this whole thing. You do not need to be a mechanic to drive. You don't have to understand how the engine works or what the transmission is doing or any of the electronics. All that crazy complexity, it's hidden away, right under the hood.
And that idea of hiding the complicated engine and just giving the user a few simple controls, well, that is exactly what we're aiming for in programming. So let's pivot back to software. What if we could build our programs to work just like that car? Simple, easy to use on the outside. Even for another programmer, while all the really messy, complicated stuff is tucked away completely out of sight. Well, it turns out we can. And this idea has a name, abstraction. When you boil it down, it's just the art of hiding all the complex behind-the-scenes details and only showing the stuff that's absolutely necessary. It is, literally, hiding the engine of our code.
You can also think of it like this. Abstraction is all about creating a simple user interface for a really complex system. The steering wheel and pedals are the car's interface. In our code, we build these same kinds of simple dashboards for other parts of the program to use. Okay, so in a language like Java, we have some specific tools in our toolbox to build these kinds of blueprints. Let's look at the two main ways we pull this off. So in Java, you've got abstract classes and you've got interfaces. Let's start with the one on the left, the abstract class. Think of this as like a partial blueprint. It can actually have some methods already built out for you. This creates what we call an is-a relationship. For example, a Corvette is a car. Simple. But now look at the right side, the interface. This is a pure blueprint. It just defines a list of abilities. This is all about the can-do relationship. A class can promise to have many different abilities. So a car can do driving, but hey, so can a robot or a drone.
And for now, let's just zero in on interfaces because they are abstraction in its purest form. An interface is like the ultimate contract. It doesn't care one bit how you do something. It just says, hey, if you're one of my kind, you absolutely must be able to do these things.
And here's what that looks like in actual code. It's beautiful, right? We've made an interface called vehicle. This is a guarantee. It says that anything that wants to call itself a vehicle, doesn't matter if it's a car, a motorcycle, even a spaceship, it has to have a way to start, stop, and turn. This right here, this is our digital steering wheel and pedals.
So as we start to bring this all home, it really comes down to this simple but incredibly powerful idea about what we should be focusing on.
If you remember one thing, make it this. Abstraction is all about focusing on what an object needs to do, and completely separating that from the nitty-gritty details of how it actually does it. The what, not the how. That's the whole game.
So, why do we care? What's the payoff? Well, it's huge. First, it makes insanely complex systems way simpler to think about. It also lets teams work at the same time. One team can build the engine while another team builds the dashboard, and as long as they agree on the interface, it all just plugs together. And finally, it makes your code so much more flexible and easier to reuse later on. So I'm going to leave you with this thought. A car is just one example, right? Every time you use a TV remote or a microwave or even tap an icon on your phone, you're using an abstraction. You're using the simple interface to a complex system. So where else do you see it? Once you start looking for it, I promise, you'll see these amazing hidden engines absolutely everywhere.